circular motion part 1. That means the basic of horizontal circular motion I have given. So today some applications related to horizontal circular motion in another we will discuss. So this is the question is given. So the system is rotating in this figure. There is a mass m is there. Is rotating about the z dash axis. And the mass is connected with the help of a one this is support, fixed support with a string of massless string. So tension is T. He is asking to find out the tension. Find the value of x when tension is equal to 32 power 1 by x is given. So automatically the answer will be 2. In that no doubt at all. Why means tension means it will be in ml omega square. Okay, in the square term. So it will be in the root will come, right answer? Something in the root 1. And here if you see theta is equal to given 45. If other than 45, that will be some other thing. It is not 2, something. But here theta equal to 45 is given. This also 45 is given. So automatically answer will become 2 directly right now. So how to solve this? So process first of all, not for answers here. So we are learning this. So in horizontal circular motion means this mass is revolving with radius r around this z axis in this circle, dotted circle, right? Black letters. So now as usual, according to NLM free body diagram, finding by taking the all applied forces. So this diagram help you to understand that. That is, so normal force perpendicular to the contact surface, tension mg. These are the forces. So here friction is smooth surface we place here. Friction is there means that last I will explain. We'll take frictional force also right now. So here n resolve into two components. Here anyhow theta equal to 45 only, no need to worry. So this will become theta 45, this also 45, this also 45. So 45 is given, no need to think about worry. Right. So wherever the theta is 45. If 30, 60 is given means where 30, where 60 will come. That will be confusion. So here 45 is given means here also 45. Here 45 means here also 45. Here 45 means here also 45. So that is also right. So now equate the forces in horizontal direction and vertical direction. So horizontal and vertical directions. So T resolve into T by root 2, T by root 2, N resolve into N by root 2, N by root 2, Mg also resolve into Mg by root 2, Mg by root 2 because they are horizontal circle, means their angle is 45 and they are moving in horizontal circle. So now by equating these equations you will get, so in the direction of vertical direction, T and N above direction and Mg downward direction, therefore N plus T by root 2 means sin r cos 45. So actually here T cos theta and N sin theta. Generally, if theta is here is given, here theta is given, that will be 90 minus theta. Okay, N cos theta plus T cos theta is equal to Mg. Okay, N cos theta. So see, means for example, thetas are given separately, then which equations you will take, I will explain. See. So this is theta means here theta is given with inclination. If they have given here theta, z axis, this is 90 minus theta. Okay? 90 minus theta. Otherwise, theta, if we take theta with any angle, we'll find out. This is a normal, right? So in case of normal, horizontal and vertical component. Therefore, normal. So here this is theta means this is also theta. So go with alpha. This is theta means 90 minus theta. This is also theta. Therefore, n cos theta in vertical direction, mg direction cos theta. So whereas coming into T tension, so this is the T is given. So T also resolving into two components. This is T. So here theta. Therefore T sin theta. So mg, you know, mg cos theta and mg sin theta, how it will be resolved, right? So no need to explain. So now in vertical direction, n cos theta plus T sin theta. Theta is the inclination angle. So remember this. Here in this problem 45 is given. In other problems they can give 30 60 or 60 60, 30 30, 37 53, 53 like that, any value. Okay. Then this is a free body diagram equating in vertical and horizontal direction. So now in horizontal direction, this is the relation. So towards the circle, horizontal circle, along the radius, there is only n component will be there. So in the diagram, you can see in diagram horizontal circle. So here towards the radius only n component is there, and outside t component and mr omega square. Mr omega square in the horizontal circle is always outside only, you have to consider. But this is a centripetal force, but it is taken on the particle again opposite to the external force. So mr omega square, that is centrifugal force or pseudo force, you can take this is. So now by solving 1 and 2 equations, you will get 4 root 2. Finally, tension is equal to 4 root 2 will get, that will be 32 over 1 by 2. These two equations only helping. Diagram and two equations. Remaining and all calculation part you can calculate. And here one more point in calculation. R is given. So sometimes in the problems they will give R, radius of the circle. They will give this distance they will give. But here in this problem is given, if you see 1 by root 2 meters. The block is not more distance 1 by root 2 meter from the point of O. For example, here point of O if you take, this is about the axis. So from here, this point, this block is 1 by root 2 meters only, not more than that. So this is magnet. And now R is equal to opposite to this 40, given 45. Therefore, R value is equal to L sin theta. Hypotenuse into sin theta. So then you will get 1 by 2 meters R value. So now you substitute here all the equations, you will get answer, required answer. So now coming into next one. So this is very, very important. On this only nowadays, means in 2023, 2022, they are concentrating like these models. So that is, the normal aberration is equal to the tangential aberration. Mean that is equal to theta equal to 45 approximately. Normal approximately what? Exactly theta equal to 45. Normal aberration is equal to tangential aberration. We know in circular motion always, in circular motion, normal aberration and tangential aberration always perpendicular. Tangent and normal, that means perpendicular. The resultant will be like this. This is the resultant aberration. So only the aberration is constant in magnitude, but varying with the direction. So if you take here, it will be in this direction. If you take here, it will be in this direction. So aberration in the uniform circular motion is not constant. It will be varying. So somebody have doubt that direction and magnitude are both are constant only. Now that means always towards the center. So that is only normal aberration towards the center. And tangential aberration is always away from the tangent. So point to point, tangential direction will be vary. Point to point, direction of the aberration along the motion is different. And always normal aberration towards the center. In that no doubt. Normal aberration means it is constant, we can say, because direction is fixed, and the same way aberration also v square by r in uniform circular motion. That value is fixed to v square by r towards center. So constant we can tell. But if you take direction point to point, it will be vary. And aberration, net aberration is equal to in previously root over a n square plus at square we studied. That will be resultant of a n and at. The direction is varying. So compulsory aberration is not constant. So magnitude of aberration, it will be the same, right, every time. So now coming into in these problems, a n is equal to at is given. And at t is equal to 0, it has some initial angular velocity omega naught. So in the question they have mentioned at t is equal to 0, angular velocity is omega naught. Then after some time t, omega is equal to how much? Angular velocity is how much? And how much angle is covered, distance covered. Angle or distance. Distance means r theta. R into theta I can. Means it is length of the arc. S is equal to r theta distance. Where you know the theta. Otherwise S is equal to, in terms of, so length of the arc you can write. Length of the arc is always, therefore length of the arc is equal to formula theta by 360 into 2 pi r. You know theta, this will be fine. R theta. Right, this is already studied. Right. So now an equal to 80, from this given information I will take as r omega square equal to r alpha. And here, so v equal to r omega we know, where constant uniform speed. So then omega square equal to here alpha, that equal to d omega by d theta. Since alpha is angular aberration here, that equal to d omega by d theta. And now we can write integration omega square and that side dt will come this side. 0 to t, at t equal to 0, omega naught, t equal to t, omega I want to find out. So 1 by omega square integration, minus 1 by omega, that is the right value. So from that I got omega value. Omega value is equal to omega naught by 1 minus omega naught into t. You can tell that it is very simple now, sir. Omega is equal to, anytime omega is equal to omega naught plus alpha into t. So this is there after t seconds. This formula is there, right? Then why you have to find like this? What is this formula in the case of when? So this is when AT and AN are equal. So this from the given condition it is correct. So generally, if it is moving with alpha is constant angular velocity, angular acceleration. So then you can find out this formula omega after t seconds omega equal to omega n plus alpha t. So there AN and AT are not equal at the time. Those two are different. So when AN equal to AT, that means R omega square equal to R alpha, then the omega value is equal to the formula. Okay, when omega naught is given, alpha value is also given, then directly omega equal to omega naught plus alpha t is over. But these all the values are not given and given the condition. In this condition, omega after t seconds is equal to the formula. Right? So now, otherwise here you can write omega minus omega naught by t. Then also maybe you will get, will not get that in the case omega will not get that. Alpha value are substituting that. So this is only correct. Right. So now here in the time t seconds, how much angle is covered or how much distance is covered or displacement. Distance, displacement equal to 2 r sin theta by 2 always in the circular motion. Displacement between the in t seconds of time is equal to 2 r sin theta by 2. I have explained in the circular motion one concept, right? So there we discuss that. Now see here omega I got here omega angular velocity after t seconds from the given condition a n equal to 80. Then here omega equal to d theta by dt means the angular velocity is equal to the rate of change in angular position or angular displacement. Rate of change in angular displacement. We studied this already. So from that integration, we will get this is very important. This is see e power minus theta is equal to 1 minus omega t. So he's asking to find out the time. Therefore, time is equal to 1 minus e power. So this is theta. Theta is equal to this is what is that angle turned is equal to theta is equal to ln of ln. Not log 10 you can go. Otherwise ln of 1 minus omega t. So this is the answer. So theta is equal to minus log of 1 minus omega into t. So this is answer. So now time also is asking to find out what time. Our time taken to cover this angle is how much? To cover this much angle, something quarter circle or full circle, half circle or some angle, to cover some angle, how much time it will take in this case when the particle is moving in the circular path with the condition a n equal to 80. So to find out that here from this apply both the sides e power theta is equal to means minus e power theta is equal to 1 minus omega t. So here it is coming. So now t is equal to e power omega t is equal to 1 minus e power minus theta. T is equal to this is the answer. Finally, this will here in the place of theta, I can write s by r. S is equal to 2 pi r for one complete circle. One complete circle t is equal to time period t. This t is equal to here time period will go. Means one cycle already over. Then only s equal to 2 pi I can substitute 2 pi r. One cycle. Okay, that's why it is changed into 2 pi. If not, that is a time period. It is not the time period. That means the theta will not be equal to s by r. Theta equal to s by r only, but s is not equal to 2 pi r. So this formula will not come. This formula when t is equal to time period. So you have to remember 1 minus e power minus 2 pi by omega naught is the time period formula. This is right. In terms of v, you have to substitute means r by v into 1 minus e by 2 pi. So like this one question is there. See, yes, here. So now see the question. A car is moving on a circular path of radius is given 60 meters. Tangential acceleration and centripetal accelerations are equal. This is the condition is given again. The time taken by the car to complete the first quarter revolution means in the place of theta you have to substitute pi by 2, right? So then already you have a formula t is equal to r by v into r omega naught or r by v because v is equal to r omega only. So omega naught equal to v by r. Then denominator is there, therefore r by v will come. R by v means, so this is 1 by 4. Here omega naught equal to 1 by 4 I substitute means 4 will come. So this already formula is there. Again here I have explained everything how the formula is coming. So answer is 4. So here given a into e power 1 minus 1 by e power 1 minus e power minus pi by 2. The a value is asking. So I find out r by v into 1 minus e power pi by 2. So this is the answer. So like this model of problems they can ask on this topic when centripetal acceleration is equal to normal acceleration. See here one tricky question, one more tricky question, and it will be logical question here. See. So position vector of particle moving in a circular path is given. Position is given. At t is equal to t seconds, the particle is here in xy plane, is moving in xy plane also. So this is the position is given. So here this velocity, this is r bar, the velocity of this one will be in this direction, 2t I cap and 4j cap. So the velocity of this particle is equal to, so in this direction. So now velocity is making some angle with x-axis, that is how much will come? Tan theta, what equal to Vy by Vx. Then theta is the angle with x-axis I have taken, tan theta. So 4 by 2t, at t is equal to 1, it will be 2, tan theta equal to 2. From that you will get this triangle. Whenever tan theta is something value is coming, to find out the sin theta and cos theta, triangle you take, right angle triangle you take and find out this. At t is equal to 1 second, the velocity vector making angle tan theta 2 with respect to x-axis. Now they are asking, here questions are normal aberration is asking. So normal aberration. So here you have to remember, already I have given one question like this. Normal aberration is equal to, so d into v bar by dt. So rate of change in velocity. And aberration also. Aberration is equal to rate of change in velocity by t. So normal aberration is equal to v square by r. Speed, magnitude of speed square by r. The same way, at is equal to, so this is aberration, dv by dt is aberration. So normal aberration is equal to v square by r. So here dv is very very small, then only you will get v square by r. So this is normal aberration is equal to dv by dt. dv is very very infinitesimally small. So then only this formula we got v square by r, right? So in explanation I have cited things already. So at is equal to d into the rate of change in speed, not, so it is not the velocity, speed, rate of change in speed, r omega, v equal to r omega. So remember this point, means tangential aberration. So your speed is equal to constant, suppose. Speed is equal to constant. So in uniform circular motion, then at is equal to 0. So an is not equal to 0 and at is equal to 0. That means what? Uniform circular motion. Uniform circular motion. So an is equal to 0 and at is also equal to 0. So this is translatory uniform motion. Uniform translatory motion. Okay, na? So this you have to remember. So I have given already, I think so. Not given means here. So now since tan theta I got is asking to find out tangential aberration, normal aberration. And here I got aberration is equal to, means again velocity derivating, I am getting the aberration. So a is equal, it is not the normal aberration here, remember this position vector and giving the aberration dv by dt is the total aberration is giving 2 I cap, means magnitude of aberration is equal to 2. So now in the circular path, this aberration is always in the direction of resultant of an and at. So therefore at is equal to a sin theta will come, an equal to a cos theta in the circular motion, in the circular path. So the aberration is the resultant of 2, at and an. So aberration I got 2 I cap. So aberration in xy plane, it is along the I cap. So aberration is along the I cap is given. That means x-axis. So now if I want to, here already 2 I cap came. So therefore at and ay are in the direction of perpendicular to I cap. That means, so this is the resultant. So one is either y and j, positive y, negative j, or negative j, positive k, right? Like that it will be. So now at and an, at is tangential. Therefore, if theta is already along the x-axis we have taken, therefore at will be tangential direction, that is a sin theta, an equal to a cos theta. It is over. So now we are along the x-axis. So in xy plane, so here is given. So this will be, it is rotating like this. So now an is cos theta and at is sin theta will come. So at is equal to 16 by 5 meters second power minus 2. And a is equal to an is equal to 4 by 5 meters second power minus 2. The resultant will be is a root over this one. If you do now, you will get a equal to 2 only, magnitude 2 will come. And radius is equal to root 17 meters. So this is about radius vector, position vector, right? So this is about finding the normal aberration, tangential aberration in this case when position vector is given. So now next problem. So here see, these are the one another model, another type of model here. So a ball of mass m is placed on a smooth table, is attached to one end by a horizontal light rod of length L. So here one end is vertical shaft. This is the vertical shaft. This is rotating about this shaft, this ball, and given here there is a resistance force is there when it is removing, that equal to minus BV is given. So tension in the rod is asking to find out. So now tension is equal to, anyhow it is ml omega square. Here R is equal to L is given, ml omega square. It's very clear. No friction here, smooth table. So no friction. Friction is there means you have to take consider the friction here again. And omega equal to So here MEAT means so it is rotating like this. No? This is MEAT. So here resisting force is equal to minus BB. So not in this direction it is. It is resisting the motion MEAT. So MEAT is equal to SB. AT is equal to R alpha. Substitute now. All you will get the answer like this. So alpha equal to B omega by again alpha is equal to I can write. So he's asking to find out here tension. So ML omega square omega I want to find out. So to find out the omega, change this alpha is equal to d omega by dt. Here t I don't know, therefore I am going to write acceleration in terms of velocity and angular displacement, angular velocity omega into d omega by dt. So from that dt means I can find out s into means delta theta or theta is equal to r by s by r because s is equal to r theta. That's why because in given is asking to find out the distance only. So distance s moved by the ball. That's why I am changing into d theta here. So according to question, you can ask me why can't you find out here alpha equal to d omega by dt according to that. Yes, you can find out if they ask clear time. But they're asking the tension of the rod as a function of S they're asking. Therefore, we have to change S means S is equal to R theta we know. Then theta is equal to S by R. So alpha is equal to omega into d omega by dt over. So now already we know that is equal to minus b omega by. So integrating and we will get consider answer. So that is answer. Means in mainly choosing the right formula makes problem easy and correct answer. So this is only in physics. After reading the question, which model, which method you have to follow. So that makes less time to solve the problem also. So you are taking different formulas and different ways you are prolonging. So somewhere it will be wrong and it will be affect the other questions in mains examination. So you want to know the exact formula, exact method to find out the right answer. Only the way is practicing more and more problems by referring the books. Only one book you are preparing and one method, any one method you are following means will not succeed. Number of problems, number of books. Here I am giving only some difficulty models. What generally we feel difficult. This is not difficult. When you know this will be very easy. It is not difficult. Without knowing, small thing also will appear as a very difficult. Right. After knowing, it will be easy. And right. You can see here. So this is the on the table two grooves are there. So along the grooves, two balls A ball and B ball are connected with the point O. Now point O means this table rotating about the point O. The table is rotating about point O, and 1 kg, 2 kg are given. Then asking the find out the tension. Find the initial tension in the string. Both the blocks are initially the distance between O to A and O to B is 3 meters. That means radius indirectly is given radius here. Distance 3 meters from the point O means the radius are given. So now here if you see, so this it is in the groove fixed means it is fixed between the grooves means so no acceleration. Our friction is there and they are moving along. That means here only m r omega square is there, tension will be t equal m r omega square is also t equal m r omega square. But in this groove they can freely move. There is a smooth only, friction is not there. So they can move, right? If they are moving, they have a acceleration. So consider the acceleration. This why here you are taking acceleration is the point. So without taking acceleration, only t and mg mr omega square, and here t and mr omega square, not give the answer. Because the system is like this. When it is rotating, these two freely can move in the grooves, so they are getting acceleration also. So write the equations for black A and black B with the acceleration, then you will get the answer, right? So now by considering the acceleration's proper direction and calculating means you will get answer. Similarly, next problem. So this is already I discussed, I think so, same model, right? Next coming into here, next model of question. So in horizontal curve road is given. So why I have mentioned this horizontal curve road means, so when the block is moving on the curve road, we have a three models. That is on the curve road, one is without friction, with the friction. That means here safe turn depends only on friction. Depends only on friction. So only with the banking. So theta. So I will explain three ways. So both banking and friction, third way. So this is horizontal circular road of radius r. The circular path have radius r here. So in this case, so we are depending safe turn only based on the friction between the tires and road. Therefore, friction is equal to providing the necessary centripetal force. So at this instant, the velocity of the vehicle is equal to v. At the instant, velocity of the vehicle is equal to v. Therefore, it has a mv square by r is the centripetal force. So that equal to the frictional force between the tire and road. It will take shape turn. If this mv square by r means you are moving with more velocity than required velocity, limit velocity, it will go out of the path. That means limit friction is there something mu mg, that is, and with your velocity of your vehicle and maintenance velocity at that point, this r value is fixed there. So it is more. The mv square by r is more than mu mg. Then the moves away out of the circle, out of the path, go away past more velocity. So then limit velocity less. Then friction is more, your velocity is less. So it will be fall inside. So limit velocity how to maintain. Now only with banking, not friction. I'm not depending on friction between the tires and road. So only depending on banking of angle. Here banking means outer edge of the road. In some of the turnings, outer edge is always thicker. Outer edge thicker than inner edge. So like that we are making the roads. This is the elevation. So this is the thickness of outer edge than inner edge. So constructed like that. The angle between the line joining outer edge and inner edge is called banking angle. So now the force on vehicles are like this, normal force. So here normal force is equal to mg. In this case, the normal force is equal to mg because horizontal circular road this is. The vehicle is moving in horizontally. So there is no banking or no elevation like that. So when there is elevation, normal force makes some angle with the horizontal. So normal force. So therefore n sin theta. So here theta with horizontal road, the normal force making some angle theta. So this theta is inclination angle. So n sin theta equal to mr omega square, n cos theta equal to mg. So then v is equal to rg tan theta. Only friction is there means mu is equal to v equal to mu rg. Only banking is there means the theta we have to maintain. So same velocity more means it will go out. Velocity less means it will fall inside the. That is well known. So when both are there, so both friction and banking angle we are depending. Then how to find out the velocity. So now if you see, so here n sin theta component mv square by r, n cos theta component here n cos theta and mg. So these are the forces are acting generally. And here we have to remember friction what direction it has to act. So up of the incline or down of the incline. So the friction is acting down of the incline, along the down incline. Then V is maximum. The maximum limit taken apart. If friction is up of the incline, then V is minimum. So I'll tell why it is minimum. You know. So V is minimum velocity than limit. How much velocity need to take shape turn here? Less than that velocity the vehicle is maintaining. That means n sin theta component is more because of banking angle. N sin theta component more means it will fall down. That means to balance n sin theta, mv square by r component will be added with the friction. So here f cos theta. F cos theta term is adding to mv square by r to balance n sin theta to take the shape term. So when f is up the inclined plane only, then f cos theta will come and add here. When your vehicle velocity is less, then n sin theta component due to banking angle will be more. There is a chance to fall inside. That is the reason f cos theta friction is acting upwards, above the inclined plane you have to consider. Then equations you add means in vertical direction n cos theta plus f sin theta equal to mg. In horizontal direction n sin theta is equal to mv square by r plus f cos theta. That will become this side. F cos theta component is coming this side. So now we can add means v minima will come. Similarly v maximum. So v minima means denominator is plus 1 plus mu tan theta minus rg into 1 plus mu tan theta denominator. So denominator is more means the fraction will become less. Therefore, V minima is the fraction of tan theta minus mu by 1 plus mu tan theta. Therefore, to get the minimum value, 1 plus mu tan theta means already minimum velocity. So now denominator is came maximum. So to remember V maximum and V minimum formulas, I am giving this clue. Denominator will be negative, numerator will be positive. And sin theta cos theta will confuse, right? That's why tan theta I remember. Tan theta minus mu 1 plus mu tan theta. So this is about banking of roads with friction, only banking. How to take the safe turn in curved roads, on curved roads. So two questions are given here. Here horizontal road only given. Therefore, V is equal to mu Rg in that no doubt. Banking means V is equal to Rg into tan theta. In case of banking and both are there means V maximum, V minimum formulas have given. So those formulas and I'll note a point and remember this is answer. Now next, so this is another model. This type of model will be used in many cases. That is simple pendulum KSHM, simple pendulum rotatory motion and work for energy NLM. So this is pseudo force you have to consider here. It is moving roof of the car. Car is moving with the acceleration with the speed is given constant speed is moving acceleration 0. So then 20 meters second force. The car is moving in a circular track. The radius of the track is equal to 40 meters. So moving in so theta with the vertical is asking to find out. So because of in circular path is moving with constant velocity, there is a centripetal force will act on this particle. So now the particle will be raised. This is the theta. Centrifugal force will act outwards. So like this. So that equal to mv naught square by r. So the radius is given. So theta is equal. Theta you need to find out. So tan theta is equal to v square by rg. So substitute the given values, you will get theta equal to pi by 4. So the same thing, one more model they will ask. So here there is a rotating drum is there. The vertical shaft. Here the particle is connected. Particle is suspended like this along this one. So now it is making horizontal cycle. So then theta is equal to how much? So theta is equal to here tan theta. So mv square by r, because of this velocity it will get mr omega square in outwards. So that which will be equal to t sin theta. So now you are substituting, you will get answer. Right. And sometimes here r plus r sin theta also will come. That one more problem I use. So in this problem we have taken horizontal road. It is moving with the horizontal cycle road. So now coming into the same model, if it is moving on a bank road, the vehicle is moving on a banking road. So this one is having radius r. The circular path have radius r. The car is here. So on the roof, one's mass is suspended. So because of here some velocity it have centripetal force. So now this one is having mr omega square. So in this case, so I need to find out here this angular velocity is how much. So now if it is very clear from the diagram, mr omega square is mg tan theta. Tangential force you can consider here. So after phi bar diagrams, you will get this mg tan theta, tangential force, which is equal to mr omega square. Here r is equal to m into, so this is the length. So r equal to capital R means radius of the circle plus L sin theta, which is equal to mg tan theta omega square. Therefore omega square equal to g tan theta by r plus L sin theta. Then omega is equal to root over g tan theta by r plus L sin theta. L sin theta is radius of only this horizontal, means the particles horizontal circle, this radius. But this is on the track of radius r. Therefore total radius of this particle mg tan theta, which is equal to m of r plus L sin theta. Total radius this one. So then omega equal to this answer. So like this models are there. So thank you everybody.